All right, this video is for the fourth quarter exam for CCP statistics. All right, it says a sports writer wished to see if a football filled with helium travels further on average than a football filled with air. To test this, the writer used 20 adult male volunteers. These volunteers were randomly divided into two groups of 10 subjects each. Group 1 kicked a football filled with helium to the recommended pressure. Group 2 kicked a football filled with air to the recommended pressure. The mean yardage of Group 1, which is our helium group, okay, so we've got helium and we've got air. Okay, both have n equals 10. All right, so the average on the first group was 32 yards. The average standard deviation of 9. And the second group was 27 with a standard deviation of 6. All right, assume the two groups of kicks are independent. Let mu1 and mu2 represent the mean yardage we would observe for the entire population represented by the volunteers if all members of this population were kicked, respectively, a helium-filled and an air-filled football. All right, assume the two sample T procedures are safe to use. What is the 99% confidence interval for mu1 minus mu2? All right, so we go into our AP Statistics app. Okay, and I'm going to run basic statistics. No, I'm not. I'm going to go to the next menu, and I'm going to go down to confidence interval. All right, and we have two sample means. So I go to the other menu, and I'm looking for a two sample mean 1 minus mean 2, okay, between the z and the t. And they're already talking about t's, but we used s of x for standard deviation, so that indicates that we're going to be using a t-test, not a z-test. All right, so for the first one, x bar 1 is 32. Oops, 32. N1 is 10. S of x1 is 9. Okay, x bar 2 is 27. N is 10. Standard deviation 6. And we are going to the 99% confidence level, so we'll put in 0.99. And when I run it, it's going to give me the key statistics that I need. All right, so what I have for x bar 1 minus x bar 2 is 5. The standard deviation of that measure is 3.4. All right, and our t distribution, our t variable is 3.25. Okay, now to answer the question, we have a lower of negative 6.1 and an upper of 16.1. Okay. Suppose the researcher wished to test the hypothesis that they're the same and that the helium distance is greater than this. The p-value is what? All right, so let's do that. So I'm going to exit out of this. Okay, I'm going to go back in, other menu. This time I'll go down to hypothesis test. Okay, and I'm looking for testing two means. In this one, our first n is 10. Okay, x bar 1 is 32, and then 9. The next one we have 10, 27, 6. Okay, the null is 0, which means they're the same. All right, and in this case, we had 5 again. We had the same standard deviation. In this case, the t distribution was 1.4 with degrees of freedom 9. Okay, and our p-value would be, it's a one-sided test, so I just use 0.09. All right. In both these cases, it does not appear that we have statistically significant evidence that the helium football goes further because 0 is contained in the interval, which means we have negatives and positives. And in our p-value, we are greater than 5%, so we cannot make that conclusion. All right, about 90% of young adult internet users, 18 to 29, use social network sites. Suppose that in a sample survey contacts an SRS of 1,500 young adults, internet users, and calculates the proportion p hat in this sample who use social networking sites. What is the approximate distribution of p hat? Okay, we would expect it to be normal. Okay, and we do that because the 1,500 is adequately large so that the p hat size is going to be normally distributed. Okay, about 90% is use social networking sites. All right, and the distribution, we're going to also describe its the expected value of p hat is going to be 0.9, and the standard deviation of p hat is going to be the standard deviation of 0.9 times 0.10, which is it's basically PQ over N over 1500, and this does stretch down. Okay, so let's just find that really quick. So if I did 0.9 times 0.10 divided by 1500, I end up at a really small number, square root that number, and I end up at 0.0077. Okay, if the sample size were 6,000 rather than 1,500, what would the approximate distribution be? It'd still be normal. Okay, our expected value is still centered at the same spot. The difference is that now we are dividing by 6,000 instead of 15,000, so we have a tighter, more narrow normal distribution. So if I just run it again, the square root of 0.9 times 0.1 divided by 6,000, then it means that the standard deviation has dropped to 0.0039. Okay, use the following to answer questions 3 to 6. Each person in a random sample of 2,000 likely voters, okay, was questioned about his or her political views. Of those surveyed, 1,308 felt that the economy state was the most urgent national concern. For the using the +4 estimate, P, we estimate the proportion of likely voters that felt the economy state was most urgent national concern to be what? Okay, so what we're doing here is we're going to say that p hat is going to be 1,308 divided by 2,000. Okay, we're going to take 1,308 divided by 2,000. We're going to end up at 0.654. Okay, the standard deviation of that, the standard error of the estimate, is going to be the 0.654 multiplied by its opposite, which is 0.346, and that's going to be divided by the sample size, which is 2,000. All right, so let's try that. Let's double check my number there. So I'm going to subtract this from 1, 346. Got it. Okay, so the square root of 0.654 times 0.346 divided by 2,000 is going to be 0.0106. And we've got B. All right. A 99% confidence interval for the proportion P of likely voters feel that the economy state is the most urgent concern is given by, okay, and use the +4 confidence interval procedure. All right. So what I'm going to do here is basically take the same data I had on this one, okay, and run it as a confidence interval as 99%. Okay, so program, AP stats. Okay, next menu, confidence intervals. Okay, and in this one, I'm just running it on proportion. So it is a z-test on proportion. Okay, and this one I'm going to type in without any approximations, 2,000 with an n of 2,000. Okay, and they said they wanted a 99% confidence interval. So I'm going to go from 0.626 to 0.682. Okay, so the only one that's actually close to that is A. No, 0.627 to 0.681, B. All right, so yeah, so B is the one that is the closest. All right, so I did all of this in the calculator. 627 to 0.681. All right, if we want to estimate P, the proportion, population proportion of likely voters who believe that the economy state is the most urgent national concern with 99% confidence with a margin of error no greater than 3%, how many likely voters need to be surveyed? Okay, so if I'm going to go with a 99% confidence interval, I needed z value. Okay, so I need to know that z value because the margin of error, remember that the confidence interval is stat plus or minus the z times the standard deviation of the statistic. And this piece right here is what we need. We need the standard, the error portion. Okay, so if I run the app, okay, and I'm just going to look for, whoops. Okay, so if I'm just going to go to find a Z or T. Okay, I'm looking for a Z value with a probability between 0.99 and it's 2.58. So my Z value is 2.58. Okay, my standard deviation formula here is going to be PQ over N, and I want all of this to come out to 3%. Assume that you have no idea the value of P. Okay, so if you assume you have no idea the value of P, then what you do is you use 0.5. So we're going to 0.5 times 0.5 over N, 0.03. Okay, so I'm going to take the 0.03 and divide by 2.58 and end up at 0.0116. Okay, and I'm going to say that that is equal to the square root of 0.25 over N. Now I need to square that value. Okay, so I've got a really small number, so 0.000135. I usually put it over 1 because I know I'm going to cross multiply and divide here. So I'm going to take 20.25 and divide by that number. And up at 1,849. Okay, so they had 1,844. Here we go. All right, the reason they would have had a smaller number than me is that I rounded off rather early. So if I don't round off nearly as early, I'm going to get a more accurate value here, which is probably going to be a slightly smaller number right there. Okay, use the following to answer questions 7 and 8. A local board of education conducted a survey of residents in the community concerning a property tax levy on the coming local ballot. They randomly select 850 residents in the community and contacted them by telephone. Of the 850 residents, 410 support the property tax. Let P represent the proportion of residents in the community that support the property tax levy. Okay, it says a 90% confidence interval is what? Okay, so P hat is essentially 410 out of 850. Okay, all right, so running the app, going to confidence interval, okay, and I'm doing a z-test on proportion. And the p hat value is 410 divided by 850. The n is 850. Confidence level was 90%. So I need to go to 0.454 and 0.5105. So it's like B. 454. Yep, that's it. Okay. How large a sample n would you need to estimate p with a margin of error of 0.04 with 95% confidence? Assume that you don't know anything about the value of p. So it's the same exact question as 6. So what I'm going to do here is I go 0.04, the desired level of confidence, or the desired error level, and I'm going to now set that equal to, at a 95% confidence, we know that's 1.96. Again, let's assume I didn't know that. So one way to do it is just to go to find a Z or T. Z. I know the probability between is 0.95. Okay, that's what they said at 95% confidence. All right, and it's 1.96. Okay, and here I have PQ over N. If I don't know anything about P, it's going to be 0.5 times 0.5, which is 0.25 over N. I'm going to take the 0.04, divide by 1.96. Okay, that equals the square root. So I'm at 0.02 equals the square root, 0.25 over N. I'm going to square that. Get a small number again, 0.000416. I'll put that over 1 equals 0.25 over N. 0.25 divided by the answer is 625. And these we always round up, 601. All right, according to the National Institute on Alcohol Abuse and Alcoholism and the National blah, 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 41% of college students nationwide engaged in binge drinking behavior, having 5 or more drinks in one occasion during the past 2 weeks. A college president wonders if the proportion of students enrolled at her college that binge drink is lower than the national proportion. In a commissioned study, 462 students, okay, are selected randomly from a list of all students enrolled at the college. Of these, 162 admit to having engaged in binge drinking. Based on the results of the test, a 95% confidence interval for the proportion of all students at this college that engaged in binge drinking is what? All right, so the p-hat value here is 162 out of 462, okay? And we want a 95% confidence level based on that, so we can do that. All right, so just go into our confidence interval portion of the app, okay? And again, we are testing on proportion, okay? 162 out of 462 with 462. And our confidence level is a 95% confidence interval. And it's 0.307 to 0.394. Okay, so the only one that's anywhere close to that is A. All right, now the value that we are comparing that to is 41%, okay, which is not in the interval. So we would say that we can reject that claim at the 95% level because it is completely outside of ours. So, and we would say that the school has a lower binge drinking incidence because the entire interval is below the 41%. All right, the college president is more than interested in testing her suspicion that the proportion of students at her college that binge drink is lower than the national proportion of 41%. Her staff tests the hypothesis that the true value is 41% versus the alternate that the true value is less than 41%. The p-value is what? Okay, so let's just run it and let's get what we end up with here. All right, so running the program. This time we go to hypothesis test. Okay, we're testing a proportion. The null here is 0.41, and our sample was 162 out of, let me double check, 462. And 462 was the n. Okay. Now, the p-value here is less than 1%. Okay, so it is below 1%. So the p-value here is a one-sided value, and that's what we ended up with, 0.0047. All right, which of the following conclusions is reasonable based on the p-value computed in question 10? We have strong evidence that the proportion of students at this college that binge drink is lower than the national average. We can't reach, there's moderate but not strong evidence. We have strong evidence. So we are less than 1% in accepting that null, so we are pretty darn confident that we can reject that, okay? So again, 0.05 is typically the level at which we would reject, so we are very strong evidence. Use the following to answer questions 12 to 18. In the United States, there's a strong relationship between smoking and education. And well-educated people less likely to smoke. A study in France included a sample of 459 men who were selected at random from men who had visited a health center for a routine checkup. Education is classified into 3 categories corresponding to the highest level of education, and smoking status is classified into 4 categories. All right. The proportion of men with a primary school education that are non-smokers. Okay, with primary school education that are non-smokers. Okay, so we're only talking about the primary school, 187 people. Okay, and non-smokers in that category is 56. So if I go 56 out of 187, that's going to be a 30%. All right. Proportion of former smokers with university education is, okay, so of former smokers means that we are only talking about these 125 people. And among those 125 people, those with a university education are 28. So if I take 28 divided by 125, I end up with 0.224. And that is A. All right, this is an R by C table, the number C has value what? Okay, so the number of rows would be 3. Okay, the number of columns, the C, is 1, 2, 3, 4. So the value of C is 4. Okay, suppose we wish to test the null hypothesis. There's no association between educational and smoking. Under the null, we expect the number of non-smokers with primary education is what? Okay, so this is the expected value of non-smoker and primary. Non-smoker and primary is right there, 56. Okay, so the next thing we're going to do is the degrees of freedom, chi-square, and we're going to test this using a p-value. Okay, so let's actually go through and figure this stuff out. One way to do this is to put all of this into our matrix. Okay, so let's do that. So when I go into the matrix, I'm going to edit A. Now, the number of rows is 3. The number of columns is 4. So I'm going to go 56, 54, 41, 36, 37, 43, 27, 32. Okay, next is 53, 28, 36, 16. So I've got the entire table in there without the totals, okay? And now I run the app, okay? And I go to chi-square, and my data is in matrix A. All right, and here's my current data, and the 56 is the value they're actually asking about. So on the next screen, it's going to tell me what the expected value is, and it was 59.48. Okay, so let's just do that. It was 59.48. Okay, and I'll show how to calculate that by hand in a second. When I press enter, there's the amount of chi-square accumulated by each portion of the graph, giving me a full chi-square of 13.3. And the degrees of freedom we'll get to in a second. 13.3 was the full chi-square. Okay, the p-value was 0.038. Okay, all right, so now that that's done, let's go and let's talk about how we would calculate that by hand. So the amount of, the expected value here is going to be the row total times the column total. So 187 times 146 divided by the entire table total, 459. All right, so when I multiply those together and divide, I get 59.48, which is exactly what I said. So it's 59.48. All right, and I'll write down that calculation. 187 times 146 divided by 459. All right, degrees of freedom is going to be r minus 1 times c minus 1. The number of rows was 3. The number of columns was 4. So this is going to be 2 times 3, which is 6 degrees of freedom. Okay, if alpha equals 0.005, will you reject the null? Okay, yes. Yes, we would reject the null. Reject at alpha equals 0.05. We would know, we would fail to reject at alpha equals 0.025 because we would be above it at 0.025. So if our level of significance is 5%, we would reject. If it's 2.5%, we're over it because we're at 38.8%. All right.